pressing the record button, so you all are being recorded. And I guess this will be going up on YouTube, is what we're doing now. So that's that's good. Okay. So I'm going to wait until Linda has this stuff up to start talking. And Linda, tonight, as we do some of these normal problems, I'm probably going to ask you to jump back and forth into the, like the whiteboard and draw some, rough normal curves to help us do those kind of things. Okay, so here we are with this, and this is it's 2 weeks till midterm, and some of this is commentary and some of this is content. So anyway, Linda, please advance the slide. Okay, and by the way, I am delighted. This is the first time I didn't have to write Pearson on this thing. So I'm just thinking that everybody is good with the Pearson things. I mean, they got what they paid for, and it's all good. So that's what I'm thinking. Now I'm going to do some terms of reference commentary, and I'm going to invite Linda to do some terms of reference commentary as well. And I am going to also throw it open if there's questions that people want to have and answer. And certainly your questions are welcome anytime, but I'm specifically going to pause there just for some questions. Then we're going to do some additional base theorem examples. I did post videos on this, and I hope you've seen them, but if not yet, you can see them later. And I'm going to try to avoid the examples that we did there, so these will be extra examples. We'll also do additional normal distribution examples, and then we're going to do some, looking ahead about some of the things that we're going to do yet this term. So Linda, please advance the slide. We might come back to that just to remind ourselves where we are. Okay. I think it's important that I re-emphasize sort of my macro goal and then my goals in the priority that they are, because this will help students to understand me. And some of the students, don't understand this yet, and I don't mean you in particular. I just mean that I run into students all the time who don't understand this. So I think I need to, keep re-emphasizing it. So the big macro goal is that teaching, learning, and progress continue unabated during this COVID-19 era. Now, you are going to experience turbulence. It's the name of the game here. And so it's not going to be smooth, and there's going to be bumps and things like that. But like I said before, your flight crew is very experienced. Just keep your seatbelts fastened, and we will be fine. Okay, within that overall macro objective, my number one personal objective is I am looking to provide the best content possible for the students to learn as much as they can. And so I am not, just doing trivial problems and things like that. I'm doing real problems as much as possible in the videos, and I'm not skipping stuff. I'm not diluting stuff, because I want you to get the best course that you possibly can, because some of you, all of you, deserve the best content, and that's what I'm trying to give. And I got to tell you, that's my number one thing. So that's where I am there. Now, my secondary objective, still important, but a secondary objective is I want to keep students' anxiety in check. Okay. By that I mean I don't want anybody just being wanting to tear their hair out or things like that. And so I work pretty hard at that. I have a lot of office hours. I sponsor guided study groups. I sponsor what are they called? Dedicated math assistants. I promote the Learning Commons. I have 10 office hours a week myself, and I communicate with you extensively. So that's my goal. Now, is it going to be perfect? No, there'll be some anxiety out there, but I'm trying to keep it in check, and that's my number 2 goal. It is the number 2, though. It's not number 1. It's number 2. Way down the list, though, for all this to happen is I have to give grades, so I have to give tests, And on your side, you guys want the grades and you want to get credit for this course so you can move on with what you want. So that's kind of a shared thing, but I got to tell you, that's down there third. I'm not, that's not fun for me. That's not something I like to do, yeah, and so on and so forth. But anyway, it's there. So all those things will be accomplished, but that's where my head is. Okay. So talking about that then, within that context, I am going to be providing solutions to the low stakes assessment so that students who want to learn from them can learn from them. And I'm going to be rendering these with videos. And I think I already did this with the Herbie grade point average, but I'm behind on the other stuff. But I will be rendering that pretty soon because I want everybody to get exposed to all of those things that they might have learned if they had done it. Okay, so solutions will be rendered, so learning will happen. However, it has been amazing the number of students who say, oh, I really couldn't upload it, so I sent you a 50 megabyte JPEG to your email, and my email was clogged up for quite a while with several of those. And other people say, I tried to do it, but it was broke, or things like that. Well, I was hoping that you could practice this and get to feel good about this, because there is going to be some of this that's going to be required on the upcoming thing. But I am being very generous, and this has happened in the past, with assessing these low stakes assessment. In fact, I think we've had 5 of these. Is that right, Linda?
Yeah.
Okay, everybody got 100 points on all of them. Because when I'm unpacking my email, I don't have a place to store that 50 megabits thing and things like that. And some people said, oh, I really didn't learn how to do this, and I don't know how to do this. I'm just telling you, it'll be to your advantage to know how to do that and to pay attention when we talk about the midterm protocols, because that's going to be a little bit more rigorous. But everybody is in good shape here. Now, I haven't written 100% for 5 times for everybody yet, but I will do it sometime. And that's a pretty mindless exercise, so I will be doing it. And also, and this is getting a little ahead of myself, but the college says, oh, we have to have quarter grades. I've got to tell you that your quarter grades are a little bit meaningless, okay, because there is no quarter, measurement or something like that. The big thing that's coming up for you is going to be this midterm that's coming up, and that'll count fully 1/3 of your grades. So what I did is, for the midterms, everybody got A's listed for the midterms. Now, some students sent me emails. In fact, some students sent me multiple emails asking if I got their email, and 4 of them were, did I get their email? And then the first email, when I finally tracked that down, was, gee, I can't find my midterm grade. I gave everybody an A, because it has to do with its low stakes assessment. They're scattered all over different emails and Blackboard things, and people who couldn't do it, and people who were sick, and so on and so forth. So I'm being generous there, and everybody is in good shape grade-wise there, okay, at the midterm. So if somebody says, oh, gee, I can't find my first quarter grade, your first quarter grade is you got an A, because I put A's down for everybody, okay? And that's supposed to appear somewhere in Blackboard, but I don't think many people know how that works. I did turn in the stuff, but I didn't get that. Yes, yes, Lily, thanks. I do see your note. Okay, but now comes some red stuff. Oh my God. Someone just advised me it's on my axis. The whole point of this was to move off my axis, but I'm not gonna ramble about that. Just let me get back to this. Linda knows I'm kind of beside myself on this, I think. Okay, but there's some red stuff here, folks, and do pay attention to this. Okay, so you're all in pretty good shape right now. I mean, you're all in good shape. It's 100%. But a high stakes assessment is looming. We'll talk more about that. And this will be graded tighter, because I do have to give you grades, and that doesn't mean I want to flunk anybody, but you've got to be good to get an A in this class. So I want to separate the A's from the not A's and stuff like that. And there are pretty rigorous proctoring protocols. And so what you want to do is you want to understand how this is supposed to work. And Linda and I are going to be explaining it to you and everything else, but you want to know how this works. And you do want to be able to do this stuff that night. Now, it doesn't mean I will say, oh, you couldn't do it that night, so you get an F, but we've been practicing that a bit. And so I hope you can. Another thing is fortune favors the prepared mind. And if you're looking to get an A on this test, and you have a little bit of latitude because I, kind of inflated your grade on the low stakes assessment, but prepare for this. And I think you know what you need to do. And we'll do some more problems later. Okay, Linda, advance the slide. I'm tired of this one. Okay, so quarter grades, I talked about that, and I'm not going to talk about that anymore. You got 100%. Now, the calendar midterm happens October 16th, but we're not here on October 16th. So even though that's the calendar midterm, that's not midterm for this class. So Linda, advance the slide one more time, please. Actually, it's not one more time. It's more than that. Here's what's going to be happening. So please, oops, that's too many, Linda. There. This is where I want it to be. Okay, now this is more for me than for you, but I like to check, and damn, we are doing a good course with you. We've really covered the objectives that we want to cover. And I went through, and some of the objectives that we have in the syllabus are physics objectives, and we haven't done any of those yet, but the rest of them are statistics objectives. And when I look at this, I say, boy, we're in pretty good shape on this, because I look through and I say we've done almost all of those, and 19 and 20, they're shown up there. I consider those transitional topics. We will touch upon those, but that's when we go from statistics to physics. We'll talk a little bit about that. But all the rest of those things, I say, yeah, we're either done or we're getting close to being done. You can see down here that normal distributions and confidence intervals for means and proportions is there. Those are still coming up, but we'll do those, and that's not a problem. Also, those of you who have the Sullivan book realize that we've done significant elements of chapters 1 through 5. We will have done 7 and 9 before we're through. Now I'm starting to look at the calendar. Tonight is the 29th. And Linda, you might want to point at that. That's up there where the 1 is. Okay, there she is. Okay, that's where the 1 is. That's tonight. And then we've got 2 that's going to, and you don't have to point at these, but you got 2, and that's going to be the first. That's Thursday. Then we have 3 and 4. And then the high stakes assessment for, and by the way, I checked on this and I was a little bit wrong. The high stakes assessment for both classes are going to be on the 13th. Now, if you say, oh my gosh, I was going to, get a root canal that day or something like that. Well, issues notified in advance, and actually even after the fact, except I hope we can do it in advance, will be accommodated. But you want to be telling me, but I'm really saying, no, you really want to be here that night and take that if at all possible, because accommodations are complicated for me and for you. Okay, so shoot for that. I will say more about that. The VCM class is going to be in here doing this at the same time you do the other things. I'm going to say a little bit more about that later, about VCM. Net, you're going to be doing it the same night, but the VCM is going to be 6 to 7:15, proctored 6 to 7:15, and so you come here to do that. And if you're a net person, it doesn't start at 6 to 7:15. This is something having to do with the testing center scheduling, but it will be 7 to 8:15. So it's the same test. It'll be the same time interval, but there'll be a little bit of a staggered start. So if you are a net person, and that's fine, but I'm talking more to the VCM people right now on this next slide. So everybody should understand that we're in really good shape. Linda and I are teaching you a good course, but this is the checklist for VCM testing. Now you're going to get this other than just here, but this is where it is right now. In fact, I think your proctor is going to send this to you soon. Okay, So it's the same time. And you might say, oh, it's just like normal. No, it's not. Some of you, and by the way, I'm not being critical or anything like that, but some of you slide in, late. Well, I'm glad you came, but you slide in late. You don't want to slide in late on that night because this has been scheduled pretty rigorously with the proctoring and testing center. So you want to be on time that night. And some of you, I know, duck in and out of this room. And again, I'm not criticizing anybody. I've observed it. It doesn't bother me or anything like that. You don't want to be doing it that night, though, because the clock is running. And also, I think if you read some of these rules here, it says you're not supposed to do that, okay? It is going to be proctored by the testing center staff. You will have access to Excel and the calculators that are on the PC, and Linda and I have shown you those. You will have access to those, so you don't have to worry about that. The only notes that you're to have, though, are the grace notes that I attach to the test. I will attach them, and they're more or less going to be the formulas from the end of the chapters. And there also will be normal tables, and the proctors will be in contact with you. Now, we got a little bit of time yet, but I'm telling you a lot of stuff here. And on the 4th, which is the last day before we have the VCM test here, what we're going to do is we're going to do a little bit of sharing of additional collateral, and we're going to let you check your setups a little bit. Okay, now I'm just going to read this other part to you quickly then. Okay, they are actually proctoring you, and the way they're doing it is they're looking on your cell phone. So you want to have a smartphone for this. So we're talking about install the free. So this is what you do before exam on the other side. You install the free Zoom app on your smartphone. If you already have it, you want to check for updates. You want to practice setting up your phone. Now, we're going to do that on the 4th in this classroom. So you get to practice that a little bit, and we'll see if you can do that. But you see, they want to make sure that you didn't bring a friend in who's sitting right next to you, and the friend is answering the question and things like that. They want your phone to be charged ahead of time. I don't see it here, but they used to check your ID. I don't know. Maybe they don't do that anymore. I'll double check on that. You want to have your phone charged, and you want to make sure you have a quiet, private place to test. You see, sometimes I interact with students, and there are people yelling in the background or singing in the background or, all kinds of stuff. And I understand that, but you want to have a quiet place to take this test, and you want it to be pretty clutter-free, and you want to tell others that, hey, you're going to be taking a test from 6 to 7:15. Back off and do that. Okay, you want to bring your, I'll tell you what, Linda, make sure we don't miss those questions, but okay. I don't know if I'm going to answer them now or not. I mean, we will answer them, but I'm just going to keep talking, I think. Okay, so, allowed testing materials. Now, allowed testing materials is you get to have a PC, you will get to use Excel, and you will have a hard copy of the test, including the grace notes, but those are the only notes that you have are the grace notes. So that's what you have. There are rules. Let's see. You join the Zoom session and choose device audio and turn on the video. Okay, so we do that because they are watching you. Turn off notifications on your phone and do a do not disturb. We'll practice this next time. Do not put phone on, let's see. Do not put phone on vibrate. Turn the volume down to at least 50%. Maybe that's so they can call you. I don't know. Only one monitor is permitted because they are going to be watching what you're doing here. Your work area will be checked to see that you have only permitted test materials. I'll be telling them what you're supposed to have and nothing else nearby. If notes or test materials are permitted, have them on the desk. All else should be cleared off. They will know what you're supposed to have and you'll have it. Okay. No watches, fitness trackers, or anything like that because students cheat with those. The entire test will be recorded, and so if they say, "Oh, something weird went on," then we'll have a recording of that. No breaks are permitted once the exam begins. So that's what I meant. No in and out. Okay, so you want to be mindful of that. You can review a quick video and preparation setup here. There's a hot link that you'll get whenever I give you this or whenever your tutor gives you this. You can see how this works. I've done this during the spring, and I also did it during the summer. This can work. It's not perfect, but it works. Okay, so anyway, that's some of the things that are going on there. Now, Linda, what was some of these other? There were some other questions that I think were out there.
So someone wanted to know if this means that they can't use the Zoom app that they have downloaded on their laptop.
Um, some students, you see, there's only one monitor. You see, they're looking at you on one thing, and you're working on another. So I guess what I'm going to say is that student may be able to use that if they're saying, oh, I don't have a cell phone, I have this. Okay, and it's got Zoom on it. But if that's what the proctor is watching you on, you're not going to be doing work on it. You're going to be doing work on another monitor. Now, and Linda and I can discuss with individuals issues that someone will have, and sometimes issue happen. I do want to tell you that that you will have a proctor who is assigned to you, and they will be watching you. But there's a proctoring supervisor who is a first level escalation, and I am a second level escalation. I'm going to be here, and I'm going to be by my cell phone, and my cell phone is charged. And sometimes I get called. For example, last year there was a student who dropped their phone into the toilet. We survived that incident. So anyway, you do. So I'm not saying you can't use that if you're saying, oh, Proctor, this is how you watch me on this iPad or something like that. But if they're watching you, then that's like pretending it's your cell phone, and you don't have a cell phone. Then what you have is that, and the I'm trying to think of how I want to say, and you need to have another monitor to do the work. Okay, and I don't want to do a whole lot of individual discussions here, but I think I kind of answered that question a little bit, right?
Yeah.
Now, I just saw something come up and said, what kind of questions will be asked? We'll share this with Linda, and I think Linda, when she gets to her comments, will probably tell you that there's some kind of a study guide that is there, and maybe she'll say something about that. And Linda, I don't remember when that was, but I shared with Linda and Tom Topol both, all the people that you're supposed to be getting help from. I did share the draft of the midterm, and I think, Linda knows what it is. I think it's something that if you know what you're doing, you can do in an hour and 15 minutes. I was very mindful of that. So I'm not testing you on everything, but I'm testing you on it quite a bit. And I'm going to let Linda talk to that in a little bit. And Linda maybe will answer that question, what kind of questions, because she looked at it, I think. Okay.
Yes, I did.
Excellent. So Linda will say some things to you in a moment about that. And she might say more on the 4th. I mean, you might want to look at her exhibit first. But anyway, okay. So we got that. I think I'm finished with this, Linda.
Okay. Do you want me to talk about the midterm, or do you want to go to the next slide?
Probably. But let's see what the next slide is. Yeah. Go back and talk about the midterm.
Okay, so under the syllabus tab, then I did upload a PDF of a Word document, just kind of a rough outline of what sort of questions to expect. There are 2 items at the bottom, creating a confidence interval and using Z-scores to find data values corresponding to a given percentile, that are bold and italicized. We have not covered those in class yet, so they will be on the midterm, but if you send me questions about how to do it right now, then you're on my bad list.
Okay, but Linda's, and you don't want to be on Linda's bad list either. that is true.
Yeah, the questions in general are very, very straightforward. They mimic a lot of the low stakes assessment stuff that we've already done. So honestly, if you're feeling decent about that, if you understand the solutions and how to go about doing them, then you should be in very, very good shape. And honestly, I don't expect anyone to take longer than even an hour on this test.
Well, but you will have the time, and who knows how long, that will take. So anyway, okay, that's good. And Linda did say we haven't covered it yet. We've got 3 whole class times before, or maybe 4 whole class times before then. We're going to cover some of this tonight. Anything else, Linda?
So I didn't include specific practice problems just because the questions that I did see on the midterm are so straightforward and so much like what we've seen on the low stakes assessment that honestly, that's probably the best preparation that you could do.
Okay, and Linda and I will figure out what we'll do on the 4th. One thing we'll do on the 4th is we'll, practice some of this setup stuff and answer questions, but we might bring in some additional collateral. For example, I do want you guys to see, oh, that's what the grace notes are going to look like. So anything that's not in the grace notes you want to have inside your head. Somebody asked a question, Linda, and I didn't catch it. Did you see it?
Yeah, so they're just asking how else they should study. Reworking the problems, of course, rewatching the videos, taking notes for yourself, just general study preparation. I mean, there's really nothing specific.
The grace notes will be at the back of the test, and on the 4th we'll come in and show you what the grace notes look like, okay? So you'll know it then, it'll be fine. Okay.
And Michaela, the videos that were not posted on Blackboard are already on YouTube if you check the announcements.
Okay, let's move on then, Linda.
Okay.
Oh, you might need to, no, not Blackboard Collaborate, but you might need to log into Blackboard because and actually that depends a little bit, but there could be a data file on Blackboard that you might have to do something with. So, but I mean, I'll make sure that the proctors know what you're allowed to do. But you don't go to Collaborate, it's a Zoom event. Okay, so Linda, here we go with this one. And I'm just going to talk a little bit about this. And Linda, instead of, and I'm being very mindful of the time that we have, the videos, I think, were pretty good on this, even if I do say so myself. And so what really happens is Bayes' theorem, and Linda, if you can point here at some things that I'm talking about, here's what usually happens in the setup with Bayes' theorem. Over here, where Linda's pointing more or less, there's something that happens, and there are different states of nature. And so you see there are events A, B, and C that can happen. And if you add up those probabilities, they add up to 1. So one of those things happens. So you go on one of those branches, not the other. That's part of the setup of Bayes' theorem. But then, once you're at A, in this problem, either E can happen or E can't happen, okay? And again, I go in a lot of examples there. But then if you go to B, either E can happen or not happen. And if you go to C, either E can happen or not happen. So there's a whole bunch of probabilities here for us to calculate, that we could calculate. Okay, so and let's just grab a few of those. And Linda, let's see. There's 7 to 18. That means there's 10 of them. No, there's not. What is there? 5 and, holy cow, 5 and 4 is 9. There's not. No, there's not. There's 10, 14. There's 14 of those. Why don't we talk about every other one? And I will read it and you'll do it. And we're just going to do the odds, okay?
Okay.
From this diagram, the probability of E given A is, Linda?
So that would be 0.6.
Okay, and again, point to it if you can up there. Okay, so it's 0.6 up there because you're on that branch, and if you went to A, then it's 0.6, you go there. Now, you'll notice that if you went to B, you'd be 0.7. Oh, that's the next. No, I'm skipping that one. Let's go to 9. What's the probability, Linda, of E's complement given A?
So that is right here, so we get 0.4.
Okay, and notice that E and E's complement add up to 1. Okay, just like that other branches had to add up to 1. Linda, I'm going to 11 now. The probability of E given C.
Okay, so that is also 0.4.
Okay, again, it's saying, oh, we're given C. That's the path we took. Let's go to 13. What's the probability of E? Now, everybody listen to Linda as she talks about what the probability of E is, because this is more complicated. And actually, there's even a calculation involved here. And this was what I said in the video was the law of total probabilities. So go ahead, Linda, please. Probability of E. That's number 13.
Okay, So to find the probability of E, what I'm doing is multiplying along the paths. So in this case, what I'm doing is 0.2 times 0.6, and that gives me 0.12. Then if I choose the path along B, then now I'm doing 0.55 times 0.7. And I'll throw that into a calculator in a second. And then if I go along path C, then that would be 0.25 times 0.4. And that gives me 0.1. So if I throw this into a calculator to get 0.55 times 0.7,
0.385.
okay.
Right?
Yep.
That better be right. I used to be good at math. Okay. All right. So
then I'm just adding all these up.
Okay. She'll use her calculator again on that probably, and she'll get 0.515, I think. Okay. No, 0.6. It has to be 0.6. Yeah, I didn't carry it. Okay. That's about total probability, and you're supposed to know about that. And so, there's that. Let's go to 15, Linda. This is the probability of A given E.
Okay. So the probability of A given E is not actually listed on this diagram. So instead, I'll need to, I believe, kind of work backwards.
She's going to do a calculation. I will tell her what to write, and it is working backwards. She's somewhere going to write equal, and that's going to be the probability of A intersect E. Divided by the probability of E. Now, we just found out what the probability of E was, and Linda, I don't remember what that number, well, no, I could figure it out.
0.605.
All right, so she's going to write that in the denominator, but the numerator was whatever she did before, and that was 0.2 times 0.6, because you see you did A and then E, and so you get that, and if you do that, you get a number, and that's the answer to that one. And again, that's a little bit surprising because you're saying, oh, if I'm at E, well, what's, what happened with going to A? But you notice I used just the conditional probability rule, and in this chapter we started using, instead of writing and, we started using intersection, and again, that's in the videos that we did that. Thank you, Linda. That was 15, I think. Let's go to 17. C given E. 17.
Okay. So the probability of C given E, so that is also not on here, so I'm also going to have to do the same thing. So this is the probability of, need to get my pen to write. So this is E and C divided by the probability of E. So that's still my 0.605 in the denominator. And then the probability of E and C, well, that was that 0.25 times the 0.4, giving me 0.1. So I'll throw this into my calculator real quick, and I get 0.165.
Okay, so that's good, and I think let's do just one other, and Linda, I know I'm changing gears here on you, but let's do number 20. That is the probability of C given E's complement. We haven't talked about E's complement yet, so let's talk about it once. So the probability of C given E's complement.
Okay, so I believe that we can just work backwards using the same kind of logic, but now we're doing the probability of E complement. So I would need to figure out what that 0.605 is being replaced by.
Pretend I didn't ask that, but anyway, here's some problems, and students can practice these things and ask questions if they have. I think we did enough of this. Let's move on.
Okay.
Okay. Now, this is similar to an example that I went over in the thing. And by the way, there is a statement of Bayes' theorem, but like I told you in the video, I don't advise even my really strong math major students to memorize Bayes' formula as a statement. Rather, I tell them to draw pictures. Now, Linda showed you a picture on that other one that was drawn for you, but now we're going to do this. We're going to draw this picture in just a little bit. And Linda, in little notes or something on the side, not on this paper, but somewhere else, you want to keep them straight because there's all kinds of black and white balls and stuff. Okay, so I'm going to read this, and she'll be capturing some of the numbers, and we're going to draw a picture, and then we're going to talk about how we can answer these questions. Okay, urn 1, that's a jar, contains 11 black and 9 white balls. That's all it's got. Urn 2 contains 3 black, 8 white, and 6 red balls. First thing we're going to do is we're going to roll a fair die. If the die is a 1, 3, or 5, we're going to select a ball from urn 1. However, if it is a 2, 4, or 6, we're going to randomly select a ball from urn 2. Okay, so the first thing we're going to do is draw this tree diagram. Then we're going to go back and answer some of these questions. Now, the first event is you're rolling a die, and that was that first event that happens. So Linda, when she switches to like, I don't know, a whiteboard or something, she's going to be drawing something, and it's got a branch, and it's going to be probabilities of 1/2 on each branch, because you see there were 6 outcomes, and the even outcomes gave you urn 2, and the odd outcomes gave you urn 1. So Linda, whenever you want to change the channel, that's good too.
All right, just making notes.
All right.
Okay. Then I will share a whiteboard and we'll start making this diagram. So the first thing we're doing is rolling a dice. So I'm going to start by having my 6 options, or I guess 2 options, because if it's a 1, 3, or a 5, then I go down this path. If it's a 2, 4, or 6, then I go down this path.
But the
now, if it's a 1, 3, or 5...
The most important number there, though, is the probability of taking the top branch is 0.5, and the probability of taking the bottom branch is 0.5.
Okay. So if I end up on the top branch, then I'm at urn 1. So if I wind up at urn 1, then I have, let's see, 11 black and 9 white. Which then if I find the probabilities of each of these, then all I'm doing is 11 divided by 20. So I believe that would be 0.55.
You bet.
And then as the complement, the 9 white would be 0.45.
And again, it's fine the way Linda wrote those, but those probabilities are associated with that line that she drew, okay? So you see this is starting to shape up like we had before. And Linda, you may, just to make this clear, I don't know how easily you can erase, but you may want to, you know, move that bottom branch a little bit differently.
Yeah. It's not very easy to erase, but I can do some creative writing.
No. Just do it. Just do it. You can do it.
So we actually have 3 options for this second branch. So this is urn 2. And let's see, we have black, white, and red. So that's 3 black, and 8 white, and 6 red. So then I have, let's see, 8 plus 3 is 11, plus another 6 gets me to 17. So I'm going to calculate these probabilities real quick, just by dividing each one of these numbers by the total. And this is about 0.176.
Write it just as a fraction, and we can talk about how they'll calculate it.
Okay.
You have to calculate all this. Wait, you can't erase.
So 3 out of 17, 8 out of 17, and 6 out of 17.
Now, we're just going to write what the answers are to these questions, and we'll go, back and forth between these, but we won't do all the multiplies. Certainly, you could do multiplies and things like that. So let's go back and see what the first question is, Linda, or do you remember it?
So part A is determine the probability that the ball is black. So to do that, we are multiplying along the black paths, and then we'll add it up. So 0.5 times 0.55 gives me 0.275. And then if I follow along the other black path, then that's 0.5 times 3 over 17.
15 over
17. Sorry, what?
15 over 17, yeah.
Well, 1.5
Oh,
over
1 half,
17,
1 half.
right?
No, I'm sorry, it's 3 over 34, sorry.
Okay, so then I'm adding those up.
Okay.
And I get about 0.363.
Okay, so that's good. Is there a next part?
Yes. So part B is determine the probability that the ball is black using the rule of total probability. Part C is if a randomly chosen ball is black, what is the probability that the ball came from urn 1? So we'll probably do that one.
Go ahead.
So that would be the probability that it is black and came from urn 1 divided by the probability that it is from urn 1, I believe. So black and from urn 1 was that 0.275, so we'll divide that by the 0.5. Oh, yeah. So that would be that 0.55. That doesn't seem right.
Don't you divide it by the total probability of getting black?
What was the
Yes.
question?
Yeah, so they're asking for the probability that the ball came from urn 1.
Given that it was
So
black.
yes, I do need to figure out what the other probability of the black one is.
That was 0.63.
Sorry, what was that?
0.363 was probability of being black.
Okay.
Okay, so anyway,
then,
yeah.
Sorry, what was that?
Go ahead.
So we're doing the probability of black and from urn 1 over the probability of black.
Yes.
So that was that let's see. Yeah, 0.275 divided by, and that was what number, Josh?
0.363 from question A.
Okay. So if I toss that in my calculator, then we get about 76%.
Okay, so this is giving us a good flavor of this. Now the one, well, I guess we've really done this because we looked at the different states of nature. Let's go back and look and see if we have another problem that we can talk about, and we'll have a new drawing and so on and so forth. So let's go back, Linda, please.
Okay.
To the
Give me
slide.
1 second.
And we might as well throw this one away because we're not going to refer to this again.
Okay.
Okay, so we did that. Here we got murder victims. Wow. Let's see if we got another one. That's kind of. All right, this is a good one. I will read this one, and Linda, you be thinking about this. And Linda, we're just going to do the drawing for this, and we're going to talk about answering the question. There's a lot of words here, though. So the CIA suspects that one of its operatives is a double agent. Past experience indicates that 95% of all operatives suspected of espionage are, in fact, guilty. Okay. The CIA decides to administer a polygraph to the suspected spy. Now, it is known that if a person is guilty, the polygraph returns a result that indicates the person is guilty 90% of the time. Okay. If the person is innocent, the polygraph returns a result that indicates the person is innocent 99% of the time. What is the probability that this particular suspect is innocent, given the polygraph indicates that he is guilty? And if you think about this, this can have to do with false positives and everything else with tests. Okay, so the very first thing is the person is either a spy or not a spy. So what's going to happen is Linda's going to draw a picture, and she's going to have 95% going one way, and that will be, guilty, and that will be 95% of the time. If they're a spy, it'll show that they are, and the other one is going to be 5%. And then the other one, they give them a polygraph test then, and we see what it is. So either they're guilty or innocent. Okay, so that is guilty. Yeah, 95% you go there, or
0.05.
0.05. There you go. Now that first one is they're a spy. Okay.
Yep.
So maybe write, yeah, spy and not spy. Okay, now they give them a polygraph test then, and either the polygraph test says they're guilty or not guilty. So Linda will draw some more branches if there's guilty or not guilty. Okay, and I think if memory serves, that was 90% of the time it will correctly find them guilty.
Yes.
Is that right? Okay, so that probability is 0.90. And that means the other one is 0.1. Now, if they're not a spy, I think it was 0.99 accurate, saying they're not a spy. So you need to think about where that is. But they're going to be, that's guilty, but not guilty. It's going to come out 0.99 down there, because that's what the problem told you. And then that's 0.01 the other place, because there were only two outcomes. Okay, and then we can multiply through. Oh, and then the question said, well, so let's go back to say, what was the question?
So the question is, what is the probability that this particular suspect is innocent, given that the polygraph indicates that he's guilty?
All right. Now, Linda's going to show you the two states where they are found guilty. So that's the first state up there at the top. She's going to calculate that probability. So she's going to be taking 0.95 times 0.9.
Give me 1 second to throw this in a calculator. So 0.855.
Excellent. And the other state of nature that we're talking about is, oh, the polygraph said they were guilty. So that's this one down here where it is 0.05 times 0.01. Now, the question asks, what's the probability that you land in that lower state that Linda just calculated? But you see, they're telling us that we found them guilty. So we're going to take that number, this is Bayes' law, that 0.00. Okay, so that's the right number of zeros, I guess. Yeah.
Yeah.
Okay, so
4 decimal places.
Yeah, so that's good. So we're going to take that number, divide it by the total probability of guilty. Go ahead, Linda.
So I'm doing 0.0005 being divided by 0.8555. And I got that by adding this number and this number.
Okay.
So throwing that into my calculator, and we get 0.00058.
Okay, so there we go, and I think that's a good problem. And Linda, we're finished with this. Watch the video if you haven't, and in fact, if you watch it once, watch it again, because again, it's got a lot of good stuff in it. Okay, so we're going then to the back to the presentation. All right, now I'm changing gears, and we're going to spend the balance of this period talking about computing normal probabilities. So, this is the second thing that was in the lectures that I pointed you at, the videos, and one of them I did myself. In fact, some of these slides are from that video, but not all of them. I'm just going to say a few things for you to remember. Okay, and again, you want to watch those videos so you have this, and read chapter 7 of Sullivan's book too, or read my slides, whichever you want to do. The area under the graph of a density function is always represents probability. So area corresponds to probability. Okay, area corresponds to probability. That's important for you to remember. And the total area under a density curve is 1. So something must happen. And the bell-shaped curve, which is what the normal distribution is symmetric, and that means we can often exploit that, and that's talked about a great deal in the videos. And we talk about things being symmetric or skewed before as well. So Linda, go ahead and advance the slide, please. I'm not trying to give you the whole lecture again. This is another thing that was talked about in the videos, and it's useful for you to know, and that is if you have the normal distribution, and this is not exactly what happens, but it's almost what happens, 68% of the data points are within 1 standard deviation of the mean, 95% are within 2 standard deviations, and 99.7% are within 3 standard deviations. That's called the empirical rule, and that holds for any bell-shaped curve. So Linda, advance the slide again. And a key thing, and you really want to remember this, and you say, oh, we've talked about this before. Yeah, I know, but we're talking about it again. The Z-score is really important. And the Z-score is, and this will be in the grace notes, you don't have to memorize it, but you got to know what it's good for. So the Z-score is Z is equal to X minus mu over sigma. And that tells you how many, and we've talked about this before, that tells you how many standard deviations you are above or below the mean in any distribution. So it can be plus if it is above the mean, it can be minus if it's below. But you see, this is going to be really important when we talk about normal distributions. On the next slide, Linda, please. Okay, what they have done in your book is they have areas here that are calculated, and the area is, and Linda, point to where that shows them what that area is representing in the little figure.
Okay.
Please. Okay, that is there in your table, and that's important because you can say, what area are we talking about? That is the area right there. So that's what the entries are in the table. And then it's important that you realize in the normal table, and you might say, is this always true? It's always true for normal tables. It's not true for other tables. But for the normal table, what happens is the Z-scores are along the outside. So Linda's going to show you what the outside is. The Z-scores are shown along the outside, and the inside of the table are probabilities. The Z-scores are along the outside, and the inside is probabilities. So for example, if that number, and Linda pointed that thing up there in the diagram, if that number there, that Z is -1, Linda, show them where they get the area from the table.
So then I'm looking for the -1, and because there's no decimal, then I'm going to the 0.00 column. So that would be 0.1587, if I can read that correctly.
Okay, now this has been, this is calculated for you. You will have access to those tables. These will be in your grace notes, but you're going to be using that, and that's how you do that. Now the next chart that Linda's going to show you is kind of the same, and Linda, up at the figure again, you'll see that, yes, it's always the area that is less than z. But this time, Linda, these are positive z-scores. So again, the z-scores are around the outside and the probabilities are inside. So Linda, let's just pretend that this is 1.96.
Okay, so then I go down to 1.9, and then I go horizontally until I reach the 0.06. So that would be right here, and I believe that is 0.9750.
Okay, so that means that this area is 0.9750. Now that means that there is how much left in the other piece there, Linda, and that is going to be
2.5%.
Okay. Now, I also really want to emphasize, and this is looking ahead, when we're talking about confidence intervals, and when you're watching the videos that I'm going to be assigning you to watch before the next time we meet, they will talk about critical values, or they'll call them Z alpha stars or something, and so on and so forth. Those are listed on this table. So you're not having to commit those to memory. You just got to know that they're there to do the confidence interval problems that I'm going to be asking you to do. Okay, so we have that as well. Now we're going to do some more problems. And again, I talked about all these things in the videos. But Linda, let's go to the next slide. But we're going to go back and use these tables, Linda, so you'll have to, kind of bounce back and forth between the slides, I suppose. Okay. And I think what we're going to do is let's advance. Boy, it's like there's something not here that I wanted to have here. Go forward. I'm hunting for something here. This is the one I was looking for. And Linda, if I were at top of my game, I would have, moved those around a little bit. Okay, that other one's just messing around with the table, and we did that a little bit. Okay, so please listen, because I actually think I explained this pretty well, and it's difficult for some students to grab a hold of. There are two spaces in these kind of problems, and there are two great problems. There is, over on the left, a thing that we call the X space. And that is normal distribution. The mean is mu, that's a Greek letter mu, and the standard deviation is sigma. And that space represents the real world. So that's the real world. It's normal. Mu is, the mean is mu, and the standard deviation is sigma. Then you have, on the other side of this, a Z space. Now, Z space is that table that Linda and I just were showing you. And that is normal, but the mean is 0, and the standard deviation is 1. It's in the back of your book. It'll be in the grace notes. It'll be what you use to solve these problems. Now, you might say, wow, how are we going to do this? Well, the wonderful thing is there is an area preserving mapping that tells you how these two things are related. And so the thing that we have is Z is equal to X minus mu over sigma. And if you think about that, that's the same formula we've talked about already. So you see, if you know X, you plug it into X minus mu over sigma, and you find Z. And you can get that from your table. If you know Z, you can solve for X and find out what X is. So that goes both ways. So there's two spaces, keep them straight, and there's two kinds of problems. Given numbers, find probabilities, and given probabilities, find the numbers. Okay, now Linda, I think what we're going to do is we're going to capture some things, and I'm going to be probably a little bit directive and just ask you to, kind of draw pictures a bit. Okay. Okay. And we will solve some problems. So let's advance this. But there's two great problems, or two spaces and two great problems. Okay, and let's go ahead. I mean, these problems are there, and students can look at them and think about them. But let's go up to, let's find a word problem to do. I'm being very mindful of what time it is. Okay, here. So we're going to work this problem. The length of human pregnancies are normally distributed with a mean of 266 days and a standard deviation of 16 days. Now, Linda is writing that down somewhere, so we remember those numbers. But I got to tell you right away, I know that's X space because the mean isn't 0 and the standard deviation isn't 1. So that is X space. Okay. The first question says, what proportion of the pregnancies last more than 270 days? So Linda, let's go to a picture now.
Okay.
And Linda is going to show us part of the board will be X space and part of the board will be Z space. So on the left-hand side, she's going to have X space, and she's going to write normal. Yeah, and there's her normal curve, and there they are. Now on that side is X space, and under that she's going to write normal 266. And Linda, I'm just going to let you talk. Go ahead.
So all I'm doing right now is kind of filling in the blanks, honestly. So our mean was 266. So, and our standard deviation was 16. So what that means is right in the middle here is 266. Whereas in Z space, right in the middle is 0, because my mean is 0 and my standard deviation is 1.
Okay, now what we're going to do is, and maybe she'll write this near the top of that whole page. So we're going to say that Z equals X minus 266 all divided by 16. Okay, now she wanted to know what's the probability that we're greater than 270. So she's going to illustrate that on the left-hand figure, greater than 270.
Okay, so 270 is greater than 266, so I'm going to just put it right there. Doesn't have to be accurate as long as I know that we're talking about the greater than. So it goes towards the right-hand side.
Okay, now it's important that you realize that's not what your table shows you, and Linda's going to show you that again. But you see, what we're really going to do is, since we have our table, we can and we will, and Linda will go over there, and she's going to mark a similar thing on Z space, but she's going to call that Z sub 270.
Okay.
Sydney.
So if I bring up the PowerPoint, then it's going to erase this.
Don't bring up the PowerPoint.
Just fair warning.
Yeah.
Don't?
I just had a quick question. Where did you get the 270 from?
The problem.
The 270 was part of the problem.
Oh, okay. Was it one of like the questions, like one of the letters?
Yeah.
Okay. Thank you. Oh well.
So I actually have the PowerPoint up.
Okay.
Let me read it for you again. So part A was what proportion of pregnancies last more than 270 days?
Oh, okay. Okay. Thank you.
Yeah.
Okay.
Looks like we have another question. The 0 and 1 came from just the Z space. That's standard.
Okay, so she's drawing something she's going to call Z sub 270. Yes,
Okay.
it always is that. In your book, it's always that, yes. Okay, so she's going to draw Z 270 over there.
So I'm just going through the calculation to figure out my Z-scores. So I'm doing 270 minus 266 and divide that by 16. So 270 minus 266 gives me -4, well, +4, and then divided by 16 gives me 0.25. So then, would you like for me to bring up the PowerPoint now?
What this means is that this is 0.25 above. I guess, but before you do that, everybody realize that we're going to do a 1 minus thing because that's not what the table is telling us. The table tells us how much is less than 270 or Z 270. Go, okay, Linda, go ahead and bring the PowerPoint up.
Okay.
But we're going to do a 1 minus kind of thing here in a bit. She's got to look
All right.
at the table. That's why she's going back there.
Just give me 1 second to find it.
Okay.
All right, so because my z-score was positive, then I'm looking in this table, and I'm trying to find where it is 0.25. So 0.2 is right here, 0.5 is right there, well, 0.05.
You either. We can't see you either, Linda. And maybe that's
You can't see the chart?
We can't see your PowerPoint, no. We're still on the thing here.
I see the chart.
Oh, you do? Okay, never mind. Maybe
I
it's
can
just,
also see the chart.
I can't. That's all right.
I can see the chart too.
You guys can see the table, yes?
Yeah.
Correct.
Yeah.
Yeah.
I have no idea
Yeah.
what's wrong with me, but that's okay. Go ahead. What's
Okay.
wrong with me is a topic for a different discussion. Okay, go ahead.
So that looks like 0.5087. I'm going to look at my version of the PowerPoint, though, just so I can zoom in on that. So 0.597. So because of this picture, though, then we are finding the complement of that, because remember, we wanted the shaded region to the right.
It all adds up to 1.
So, yes. So 1 minus 0.5987. And I throw that in my calculator, and we should get let's see, that's a 3, 1, 0, and 4. Yeah. So about 40%.
Okay, so this is an example of a problem where you were given numbers and you had to find probability. Okay, now Linda, I'm thinking I'm going to, oh wait, now I finally can see back. Now it finally changed back for me. Good. Okay, Linda, let's advance the slides. And we're looking for one of the other kind of problems. And again, folks, don't worry, I'm watching the clock for us all. So let's go to some more word problems. Here, this is a good one, I guess. Well, I guess. The time required for speedy lube to complete an oil change follows a normal distribution, a mean of 17 and a standard deviation of 2.5. I know right away, folks, we're in X space. Okay. Speedy lube guarantees customers that the service will take no longer than 20 minutes. If it does take longer than 20 minutes, no, this is the same kind of problem, isn't it? Go the other way, Linda, back away from speedy lube. There. No, that was next. Okay, let's see what else we got. Maybe I didn't have one of those. Go one more. Maybe I didn't have one of those today. Oh, this is a good one. Let's do this one. Okay, so the reading speed of 6th graders is approximately normal. The mean is 125 words per minute, and standard deviation is 24 words per minute. What is the reading speed of a 6th grader whose speed is at the 90th percentile? You see, they're telling us a probability. This student is at the 90th percentile, but we want to know what's the reading speed. So you see, this is going the other way. We're going to have to find the X. And Linda, if you can just memorize those things, and we'll do part A anyway. And we might actually, part B is a good bridge going on into something else. Yes, Sydney.
Sydney, you have a question?
How do you know that? How do you know that that's what you have to solve for X? Like, what in it tells you that you need to solve for X?
The 90th percentile tells me I have to solve for X.
That's a probability.
Okay.
That says that 90% of the students are less than that number and 10% are above. Okay, so
Okay.
Linda, let's draw a picture and at least talk about it. Go ahead. Good job. That's much better than what we would have done. So there's the 90th percentile. I'm letting you talk, Linda. Go ahead.
Okay, so basically all percentile means is that is how much of the proportion is below that number. So we're trying to figure out what the X value is here, given that the mean is 125 and the standard deviation is 24. So really I need to figure out what the Z-score is that corresponds with 0.9 as my probability.
And what this means is Linda's looking in the body of the table because that's where the probabilities are. And she's going to find the closest number to 0.9. And then she's going to read it backwards and she's going to get the number. And then she's going to change the number back to X because that'll give her a Z number. Okay, so there she's doing it. Good.
So I'm looking here in my table for 0.9. And because I can't quite read on there, then I'm looking at the actual PowerPoint. And the closest one I'm finding is 1.28 or 1.29. It looks like 1.28 is a little bit closer.
Okay, so it is 1.28 equals X minus 125 over 24, I think. I'm working with memory here, but.
Okay, so all I'm doing now is just solving for X. So I multiply both sides by 24, so I'm doing 1.28 times 24. That gives me 30.72. Then I'm adding 125, and that gives me 155.72.
How did you get 1.28?
The 1.28 came from the table.
You found the number closest to 0.9 in the body of the table, and then you looked on the outside of the table. What got you there?
Yeah, so it's a little hard to see on this, but this number right here, the 0.8993 or 0.997, I believe, then that is closer than the 0.9015 that was next to it, so I went with the 1.28. And we get that because of this 1.2 and this 0.08.
Linda, show us the very last question.
Okay.
It's part B on that one. There. Okay. A school psychologist wants to determine reading rates for unusual students, both slow and fast. Determine the reading rates for the middle 95% of all sixth grade students. And what are the cutoffs for this? That is a wonderful segue into what we're talking about in the videos I'm going to assign and that are going to happen next. And we'll start here, Linda, if we can remember that. And that's going to be dealing with confidence intervals for proportions. Okay, so we are going to be talking about that. Is this class well planned or what? I think we really accomplished what I wanted to accomplish tonight, and we'll be moving on. So time is precious. Each day must count. Before I finish that, Josh, can you stay just for a minute? It's nothing bad. I just want to ask you a question, and it's not a bad question either. If you can stay just for a minute, that would be great.
Sure.
Do the math. It'll make you strong. And stop recording, and I want to talk to Josh just for a minute.